In this lesson we're going to be covering the reciprocal function, the reciprocal parent function, which is going to be 1 over x. So if I have 1 over x, the most important identifying feature for this is that I cannot have x equals 0 because you can never divide by 0. So that gives us a nice asymptote right here. And if x can never equal 0, there's no number that I can plug in for x that will ever give me a y that equals 0. So we're also going to have a horizontal asymptote at 0. If I was to plug this in, when x is 1, my y will equal 1. As my x gets smaller and smaller, here, let me write this down. As my x gets smaller and smaller, our table, as x becomes, say, 1/2, 1 over 1/2 would be 2. As this is 1/4, this would become 4, so on and so forth. This gets larger and larger. So as this gets smaller and smaller, as my x gets smaller and smaller, my y gets larger and larger. So that gives me this curve there, and it hits that point there. And then as my x gets bigger and bigger, my y gets smaller and smaller. So it happens like that. So it curves, and it has both of these asymptotes that it lies between. Same thing happens on the negative side. When my x equals -1, my y will equal -1. And I'll get closer and closer to this asymptote, and then closer and closer to that asymptote. So the identifying features of this graph are going to be your asymptotes and, to a small extent, these identifying points. Let's look at our graph. So if I was to graph y of 1 over x, that's going to have this asymptote here. And I'm just going to do rough graphs because we're going to be drawing a lot of these. So we have the asymptote here and the asymptote there. And they want to have us graph that at the same time as we graph -1 over x. Now remember, with a negative number in front, that means it's going to reflect the graph over the x-axis. So if I have this being -1, -1, let's make this -1, +1. So we're going to get on this side something to this effect, and on this side it's going to reflect something like that. So it just reflected the graph over the x-axis. Here it's going to be a stretch. So if I had my original function was that, wow, that was way off and didn't go anywhere near where I needed it to go. This goes something like that. If the function is stretched, that means that it's just going to get taller. So instead of this point being at 1, it would be at 2. So all of these points would be higher up. So that identifying point, that's going to go up. All of these would also go up, but you're still going to be eventually hitting those asymptotes. So this guy will be right there, that point will go there, and all of these points would also be stretched. It looks something like that. Here we have a transformation inside the function. So if it's inside, it's going to be shifting it left or right. In this case, we're going to translate the function to the left fork, because it's going to be the opposite of the sign. So if I have my original parent function that looks like so, with an asymptote we have our asymptote at x equals 0. Now our asymptote has been shifted to the left 4. So instead of being at x equals 0, it should be at x equals -4. We're still going to have this horizontal asymptote, so it'll look something like that. That's got the graph will continue on that way, and it'll look like that. So it just shifted to the left 4. Here my number is outside of my function. So if you recall from all the other parent graph transformations, when we subtract a number on the outside, we're going to shift the graph down too. So let's draw our original function. Like that. Like that. All the points are going to go down to. So this point right here will come down to. Our horizontal asymptote will also shift down to. Our vertical asymptote won't be shifted at all, so he'll still be right there. So it'll look something like that. All of these points have been shifted down to. Give the function that matches this hyperbola. State the domain and range and give the equations of the horizontal and vertical asymptotes. Okay, so our domain are possible x values. And what are our possible x values? Well, this will continue on to the left forever. So we're going to have it go to -infinity. But we have a vertical asymptote at -2. So we can't have the point -2. But then we can have all of the points from -2 onward to positive infinity. So that's our domain. Our range, it looks like we've got a horizontal asymptote at -3. So we'll have all of our y values will include all the points from -infinity to -3. We can include -3, and then from -3 to infinity. So that's our range. What kind of function is this? Well, if we start with our base parent function, we're assuming that our stretch factor is 1. They're giving that to us. So we know that this is going to be a 1 over x minus h plus k. Well, we had shifted to the left 2, so this is going to be minus -2, which is going to be x plus 2, and we had shifted down 3, so we'll subtract 3. So that's how we're going to transform the parent graph for our inverse function and identify the domain and range for those functions as well.